Welcome, friends, to this series of learning containers and Kubernetes. So, in the last couple of lectures, we saw how we can deploy the Kubernetes on on-premises systems. We installed the Kubernetes on AWS EC2 instances. We installed the Kubernetes on GCP VM instances, as well as we use the managed services like Cloud Run. We use the managed Kubernetes like OpenShift, and now we are switching our gear on AWS managed Kubernetes service, that is Elastic Kubernetes Service, or it is called as EKS. Now, this is completely a full-fledged Kubernetes service, and here we need to manually configure many of the things. But what AWS provides, the platform, the Kubernetes, we no need to install manually the Kubernetes and the kubectl and other stuffs in these EKS environment. So that is readily available in EKS. Now, in this particular lecture, we will see how we can deploy our MyApp Docker container in the EKS, which will eventually connect to a RDS MySQL database, and that connection will be secure and private. But here we are mainly focusing how, for a beginner, how we can deploy the MyApp application on EKS on AWS managed service. In the upcoming lectures, we will slowly deep down how we can securely connect the MyApp with RDS, as well as how we can securely keep our services, microservices. We can deploy the secured microservices in EKS. But in this particular lecture, we are mostly focusing on how we can create a EKS Kubernetes cluster on the AWS platform, and how we can easily deploy the Docker containers inside this Kubernetes cluster. If you haven't subscribed our channel, please do it now so that you will get the notification when the new videos will be released. So without wasting any time, let's get started. So this is our architecture actually. So here we are having one EKS cluster that we will create shortly. And within that EKS cluster, we will have two nodes. This is basically, these are the EC2 instances. Those are actually running as a part of this Kubernetes cluster inside the AWS EKS environment. And we will actually create a RDS MySQL database, and this particular database can be connected from these EKS, and we will deploy our service, MyApp service, with a load balancer kind of service, and this load balancer can be accessible from the outside world. Now, we will use our favorite learning light Docker IO image, which is MyApp, learning light / MyApp, and probably we are going to use version 1.1. And that particular image we will be using to create our application MyApp inside the EKS environment. So friends, this is our learning light MyApp Docker image, and this is actually hosted on Docker Hub public repository. We use this particular image for deploying the MyApp Docker container on several platforms in last couple of lectures. So we'll be using the same Docker image, and we will be using this version 1.1, which is the second version of this MyApp image. So let's jump to the AWS console. So this is our AWS console, and this is our Cloud Shell. So we are on North Virginia region, and we are going to create the Elastic Kubernetes service. Either we can search the EKS over here, or we can simply click the recently visited EKS service. So either is fine. And now we, in this particular lecture, we will be using this management console to create the cluster. But in the subsequent lecture, we will use the Cloud Shell, how we can create the EKS cluster very easily from this Cloud Shell environment. For now, let's use to with this UI. Okay, so now we are going to give some name of this cluster, and we can say my cluster. And here we need to create one role. So we don't have any role, so we will create a IAM role over here. So this particular role will be used to allow the Kubernetes control plane to manage the AWS resources. And this cannot be changed after the cluster is created. So whatever you are going to create, that would be permanently attached to this cluster. So I'm just clicking this link, and here we are actually redirect to this IAM console, and it is already saying that AWS service, and which is EKS cluster, that is already selected for me. So that's the beauty of this link. So we can click next, and what we will do, we already see, like, these EKS cluster policy is already selected. And if we see what exactly this cluster policy is, so we can see that it is basically having all these EC2 permissions, like describe subnet, describe volumes, create security groups, create roles. All these EC2 permissions are there. Detached volume, describe available zones. All these things are there. Apart from that, we are having elastic load balancing. So if we create the elastic load balancer, then it will be helpful. So basically, it is having all these read-only permission on EC2, and as well as it is having some create security groups kinds of stuff. And that's it. So we are going to use this EKS cluster policy, and we will select next. And here we can give some name like EKS cluster role, and this is what it is saying. So let's just create the role. Once the role is created, let's get back to this console and refresh button. So EKS cluster role that we have created is selected. Now we are fine with the latest version of the Kubernetes. And here you need to select this extended policy, because standard is basically supports the Kubernetes version for 14 months after the release dates. So there is no additional cost when standard support ends. Your cluster will be auto-upgraded to next version, whereas it is having 26 months after the release dates. So this is extended support. Okay. So create the cluster. We are allowing the cluster administrator access, and we are having this default setup. Okay, and this is a very important part, which is secret encryption, though we are not using, but let me spend a minute for this one. So this actually involves the encryption on top of your Kubernetes. So if you turn on this envelope encryption for the Kubernetes secrets using KMS, so it will basically have an additional layer of encryption. But for now, let me unselect this one and go ahead with without having any secret encryption. Okay. So now it is being auto-populated. You can choose your VPC. Now, our main focus is to let you know how we can create the cluster and how we can deploy the my app application inside this Kubernetes cluster. So we are not creating any new VPC explicitly for this one, but it is recommended in the subsequent lecture when we will actually secure our EKS environment. We will show how we can create a VPC, how we can manipulate all these stuffs over there. For now, whatever we are doing, let us do it straightforwardly. We can create a subnets, and we can select or deselect couple of subnets randomly, whatever as per your need. Okay. For the security group, we already have one default security group. Let's select this one, but we can definitely create the security group to disallow or allow the traffic in between the RDS and the other environments. So for now, we are just selecting the default one. Going forward, we will see. And we are having the cluster endpoint access, private and public both. But we will see these private options eventually in the subsequent lectures. So here our main aim to create the cluster very simply and deploy the application. So let's select the next. You can create the Prometheus metrics. Use this Prometheus to check from these logs from CloudWatch. So this will give you the better visibility and observability. And we will, the subsequent lecture, we will see how we can use these Prometheus. But for now, let's keep it straightforward. Okay, and similarly, we can log API servers, audit, and authenticator, control manager, scheduler. So it will pretty much log everything, and we can check the logs from the CloudWatch, and that will basically help you to troubleshoot the things when something gets broken. But for now, let me turn off everything for sake of simplicity. Click on next, and there you are having these add-ons as well. We will come to know how this will basically help us for different purposes. And whatever is selected by default, I'm fine with that. Let me click next. And it is the review section where we can have this everything, whatever we have selected. And now let's create this cluster. All right, our cluster is creating. We can see the cluster is still being created. So by that time, let us go to create the RDS where we are going to connect our application. So let's go to this RDS console, and we can go to this create database console, and let us create one database for us. So here in this particular my app, we saw that we need a MySQL database. So we just create the MySQL one, and pretty much we can keep everything as it is. We no need to have this high availability, so we go with this free tier one. MySQL 8.0 engine is pretty much good. So for this free tier, actually, you can't use this multi-AZDB cluster or instance, anything. It will be automatically select this select DB instance. So the high availability will not be um, available for free tier, but we are okay. So we can keep this database name as MyDB, okay, or MyDB instance, okay, and master is root, and we can use the root password as root 123456. Confirm the password. Instance configuration, we are fine with these T3 micro, GP2 allocated storage is 20, is absolutely fine. 20 GB, so automatic scaling, I'm absolutely fine with that. And this VPC, our virtual VPC is default VPC that we already created, and we don't need the public access, so the subnet group is fine. And here actually we use the same security group default, and then we will eventually use our security group to allow the connections from these database to these EKS. We don't have any vulnerability zone preference. We're fine with that. And we are fine with this password authentication. No need the IAM authentication for now. All right, so our database is being created. So let's wait, and we will see our cluster is still being created. So we will wait once this cluster is done. All right, so after a couple of minutes, the cluster is created. So you can see the cluster status is active. Now, let's see what other things have been created. So I can see that API service endpoint, server endpoint has been created, and we have pretty much nothing. So if we go to these resources, we can see we have no pods, no deployments, nothing. So what about compute engine? So we can see there is no node and nodes groups are there. So it is basically created a empty Kubernetes cluster, and it has associated with no nodes. So what exactly we need to create? We need to create a node group. So maybe we can say my node group. So it will exactly create some couple of EC2 instances, and we can use these node group to actually bundle the services or microservices that we want to deploy within this node group. So we are going to create one node group for us. So my node group, and now you can see that there is no IAM role. So the role that we have created, those are basically for the cluster. We can use this link to create the role for us. And this time you can see this role is basically for EC2, having this EKS cluster that we need to create. We are actually having this role for EC2 instances. Now, here pretty much actually we need to provide the exact permission that we need to provide. So we can say EC2 container registration that is already selected. And you can see this is basically for ECR stuff. So ECR is basically the image repository for Amazon, and you can see this ECR is actually selected for ECR. Okay, and we can see that EC2 container registry read-only permission is there, EKS CNI policy, and EKS worker node policy. So these particular policies has been associated or going to be associated with this particular role. So we're going to create the role. And again, we can go to this tab and refresh, and we can see role for ECR is now enable. Now we can create next, and we can say that Amazon Linux 2 is the AMI that is going to be selected. We can use on demand or spot. So depending upon, if you use the spot instance, then it will be a little bit good for us from the cost perspective, but make sure that your master node should be on demand. Okay, and we are fine with these T3 medium kind of instances. So all these instances will be created as T3 medium. So desired size, how many nodes you are going to create? So it is saying that 2. So desired is 2. You can say minimum and maximum size for the auto scaling purpose. So maybe we can keep it as 5 for auto scaling, and minimum size is 2. That is the desired one. Okay, and here the maximum unavailable is 1. So for any kind of upgradation or the node group update, we can say that maximum 1 node can be unavailable. So we're going to select the next and then specify the subnet. So we are pretty much having all the subnets that we are having the node. Click next, and then we are going to click create one. So our node group will be created. So we can go to this EC2 in a different tab, and here in the EC2 dashboard, we can see whether these instances are being created or not. We can go to these instances running, and then we deselect the running, and in few seconds, we will see that some instances will be coming over here. And eventually we can see these nodes are being created, and now they're running. Here we can see this node group is still being created, and in few minutes we can see these node group will be available for us. So now it has created the EC2 instance. Now it is going to install all these Kubernetes stuffs, kubectl, kubeadm, etc., etc. So once they are done, it will declare this particular node group is ready to use. Now you can see this node group is ready. Now we need to connect to this particular Kubernetes cluster. So for that, we can go to this particular URL where this is the AWS white paper, and this is how we can interact with this kubectl and EKSCTL. So basically, if you were using a local shell, so there you can install the Kubernetes client, and from that particular Kubernetes client, you can connect this EKS environment. So this particular white paper is actually saying how you can install this one and update the kubectl. So this is the command which you can use to install the Kubernetes on your local Linux machine. But if you are using our Cloud Shell, then Cloud Shell is having pretty much everything. So what you can do, you can simply say kubectl version client, and if we paste this one, we can see that the Kubernetes is already installed. The Kubernetes client is basically installed over the Cloud Shell. So we no need to install the Kubernetes client in our Cloud Shell, but if you are using your local machine, then definitely you can install the Kubernetes client over there. So if you scroll down below, and you can see that there is a command like AWS EKS, and this particular command you need to run. So basically, this will actually help you to connect with your Kubernetes cluster that you have created from EKS. So this is basically the region code and the cluster name that you are going to say, so that your Cloud Shell will come to know that I need to connect to this my cluster. So I have already copied this command, and I'm just going to paste over here. So AWS EKS update kubeconfig region, and now our region of this node group is basically North Virginia, and that is US-East-1. So this is what I'm going to say right now, US-East-1. And then I'm going to say name, which is the cluster name. Our cluster name is my cluster. So I'm going to copy this one and again paste this one over here, and let us connect to this cluster. Now you can see that added a new context. Now this is the context, this is the ARN of our cluster. Basically, if you go to this cluster, you can see the ARN is there, and this particular ARN is actually the cluster ARN. So it actually added this context with this .cube.config. So basically, if you go to this config file of this Kubernetes, and you just add this context that which particular Kubernetes cluster you want to connect, it will actually do the same thing through this AWS EKS command. Okay, all right. So we have connected to our EKS cluster. Now we can basically check the AWS caller identity, and we can see that our connection is successful. Now, first we will check kubectl get nodes, and definitely we are having two nodes that are basically created by EKS, and we can see those nodes are there. So now we are going to deploy our my app over here in this particular in this particular EKS cluster. So what we will do, we will create a file, nano app.yaml file, and here actually we will specify our deployment config. But before creating this app.yaml, we need to wait for this database to be available. And if we go to this database, we can see our database is ready. So what we will do, we will actually go to this Cloud Shell, and we are going to paste this particular file, which is actually the deployment file. And here, if we go to our Docker image, we can see that we need a couple of environment variables to be declared. And these are the DB user, root password, DB host, and port. So these are going to be declared over here. So as we have initialized our admin password as root 123456, we have kept it. We provided the DB user as root, and here we need to provide our RDS endpoint. So this is our endpoint to connect to this particular database. What we will do, we will actually paste this particular API endpoint over here. And this is the entire deployment. So let me read it for you. So this is a deployment kind of YAML file, and we are going to create the my app application. And this is the match label for the selector I have created. I have kept this my app as a selector, and this is basically the template. So this is the pod my app, and the name of this container will be my app again. And this is our Docker image, that is docker.io/learning light at my app 1.1. And one interesting point, we missed that replicas. So how many number of replicas we are going to create? We are going to create 2 replicas, and this EKS cluster will be responsible to maintain these 2 replicas all the time. Doesn't matter what happens to these particular one of these pods. EKS will automatically create the replica if one of them or both of them gets died or killed, or the node location is not available in this particular region. So automatically EKS will create the replicas, and we maintain 2 replicas all the time. And here basically we know that our my app actually a Streamlit application, and that is running on 5000 port. So this is the reason we have kept this container port as 5000. And in earlier lecture, when we actually created and built this my app Docker image, you can get all the details how this particular application was created and pushed into the Docker Hub repository. So if you have missed those videos, you can definitely go to those video links, and you can check how we created this my app. But in this particular video, our main focus is that how we can deploy this Docker image inside this my EKS cluster. Okay, so we are done with this deployment, and we are going to save this file. All right, so now we are going to apply this YAML file with this kubectl command. So what we will do, we will create this kubectl apply -f app.yaml. So it will actually deploy our my app in the EKS environment. How we are going to check this one? Definitely we can say kubectl get pods and -o wide. We can see these containers are being created. So what we will do, we will just say watch, and we will use the same command kubectl get nodes -o wide, and we will see that in a minute or so the nodes are ready. So basically our pods are running right now. We can see our pods are running, and these are the containers, these are the pods basically. These are the pods, those are running, and they are running absolutely fine without having an issue. Okay. Now, how we can expose this particular deployment in external world? So we can simply say expose a service, but that will create a cluster IP type of load balancer or the node port, but we basically need to access our my app from the external world. So this time we're going to create the load balancer kind of uh, service. So in that case, we are going to say kubectl expose deployment my app, and we are providing this load balancer as a type. So if we do so, the service is actually exposed with a load balancer. So we can say kubectl get service minus o white. We can see this particular load balancer is actually created. We can also we note down this particular load balancer, and let us go to our cluster and we see the ELB, which is basically the load balancer, which is coming under EC2. So we can go to these EC2 load balancers, and we can see this load balancer is actually physically created inside this AWS environment. So we can see this particular ELB is actually created. So this is the DNS name, and this DNS name is actually matching with this DNS name. So we can copy this DNS name and we can go over there and we can paste it, and we can say 5,000 because the port is 5,000, and we can see that our Streamlit application is running. But there is one issue. Our database is not connected. So if you see that we don't have these buttons, and eventually in some time we can see this error will coming the error will be coming that the application cannot able to reach the RDS. So anyone guess why? So those who have guessed that the security groups are the reason, those are absolutely correct. So what we will do, we will go to this cluster. So if you go to this networking tab, you can see our cluster security group is there. So you can go to this cluster security. This is our security groups, and as well as we are having the RDS. And if we go to our security group, we can see the security groups are there. This particular security group, you can see the inbound. We can edit the inbound rule, and we can see database security group, and we are going to add one rule, and we are going to say that 3306 can be acceptable. And here actually we need to specify the security group for the EKS. So this is our EKS security group. You can see 14887, which is this one, 14887. So we are going to use this security group. So basically what it will do, it will going to accept all the 3306, which is the default port for the MySQL database, and this is what we are using for our RDS. So 3306 is going to be opened for any traffic that is coming from this EKS. So RDS is basically welcoming all the traffic, incoming traffic from the EKS cluster. So once we save this rule, so RDS is basically started to accepting all the traffic from our Kubernetes cluster. So you can see this entry is actually popular. So now we can see this, we got the error that the cluster cannot reach to this instance. So if we go ahead and refresh this page, and definitely we can see the application can connect to the database. Now we can definitely say EKS one item we can add, and we can insert the item, and we can see the item is successfully inserted, and we can see the item that is actually. So basically, the My App application is successfully able to connect to the RDS database. And this is how we actually able to deploy the My App application inside the EKS environment. And this My App application is actually built from the Docker image from the Docker Hub repository. In this particular lecture, we have come to know that how we can simply deploy a Docker image from the Docker Hub repository in the EKS environment. Also, we came to know how we can actually create the EKS cluster, how we can deploy the app inside the EKS cluster, and how we can deploy the Docker container from the Docker Hub, how that particular application can connect to a RDS database, which is basically not publicly available. And this particular My App application can connect to the database privately, securely inside the AWS environment. Thank you, and see you in the next lecture. Till then, be safe. Goodbye.